look at, remember that the overall title of this lesson was Applications of Combinatorics, Applications of Combinations. We're going to look at something called Pascal's Triangle. You can find it? Where we left off. There you go. Having said that, now that you're here, put your pencils down. Pascal's triangle is a number arrangement in the shape of a triangle. And I'm going to show you how to, right here, the notes from last day. Okay, let me get you a copy because it's important that you be able to follow along. Back to what I was saying. You with me now? Yeah. Pascal's triangle is an arrangement of numbers. You're going to write it out yourself in a second, but put your pencils down. I want to show you how it's generated because if you're trying to copy it, you'll miss the pattern. It starts out very easily. It starts out with a 1. By the way, it's called Pascal's Triangle because a mathematician named Blaise Pascal about 300 years ago wrote a bunch of papers on it, but it's been around for about probably 1,000 or 2,000 years. It's actually a little elementary school fun game. It goes like this. Down the edges, down the sides of the triangle, you always put 1s. So I'm going to go like this. Don't write this down yet. 1, 1. That's row 2. Row 3, 1, 1. But in the middle, you add the 2 numbers diagonally. 1 plus 1 is, that's what goes there. Except I can do better than that. That's terribly lined up. 2. 1, 1. What's going to go right here? 3. Here? 3. Next row. 1, 1. The rule is drop 1s down the sides. What's going to come? What's the next number? 4, then 6, then 4. On your own, start going. By the way, little hint, go wide and see if you can fill in the next 2 rows. See if you get it right. So you see the pattern? 1's down diagonally, and the next number is the 2 numbers above it added together. I'll freeze the screen. Let's see if we get the same triangle. Yep, that's wrong. See if you get what I got. And it goes forever, but we're not going to bother. Why is Pascal's triangle studied? Believe it or not, Connor, there's like a gazillion patterns that show up from this triangle if you look. Some are obvious. For example, you'll notice the second diagonal just goes 1, 2, 3, 4, 5. Oh, I see counting numbers. This third diagonal is kind of interesting. What's 1 plus 3? What's 1 plus 3? 4. What's 3 plus 6? 9. What's 6 plus 10? 16. What's 10 plus 15? 25. So I heard 9, 16. Sorry, I heard 4, 9, 16, 25. What group of numbers do those belong to? 9, 16, 25. If I told you the next one down would be 36, because it would be. The next one down would be 49, because it would be. What numbers do those belong to? Don't write this down. 4, 9, 16, 25, 30. What do those belong to? I got to be fussy. They're not the square roots. The perfect squares. Okay? Those show up. If you go down a few more, you'll find all the perfect cubes. You'll find 2 cubed 8, 3 cubed 20. So there's all sorts of patterns. But also, it turns out, Christina, that there is a pattern with choose. So, Get your graphing calculators out. And bring up your choose menu if it's not already there. Okay. Got your graphing calculators? And I'd like to look at the row that has a 5 as the second number. What's the second number? 5. Can you go 5, choose 0? What do you get? 1. Can you go 5, choose 1? What do you get? 5. Can you go 5, choose 2? Tell me, do you get a 10? Yeah. Oh. 5, choose 3? Also 10? Yeah. Yeah. 5, choose 4? 1? 5, sorry. 5, choose 5, 1? Yeah. It turns out the chooses are hidden in here. Don't believe me? You can try it with the 6. That's 6, choose 0, 6, choose 1, 6, choose 2, 6, choose 3, 6, choose 4, 6, choose 5, 6, choose 6. I don't know if you ever wondered, Jordan, hey, Mr. Dueck, 60 years ago, before we had these fancy schmancy calculators, how did they do chooses? Because we saw with, it's lots of factorials, it's lots of multiplying. You would actually, in the back of your textbook, have had a big Pascal's Triangle diagram, and you could find all the chooses by just sliding down and across and reading. So, we're going to put this together. What row is this? Meant to be really easy. What row number is this? 1. That's 0, choose 0. What row number is this? Row 2 is 1, choose 0, 1, choose 1. What row number is this? 3. Row 3 is the 2 choose row, but you got to start with 0. By the way, that's why there's 3 terms in the 2 choose row, because when you're choosing 2, it's choose 0, choose 1, or choose 2, 3 options. What number is that? What row? 1, 2, 3, 4, 5, not 5. What row? 6. 6. 6. So, let's put all this together. The relationship to NCR. The 4th term of the 6th row is... This is how I'm going to phrase it on a test. The 4th term of the 6th row, okay, the 4th term, I'll scroll down in a second. The 4th term of the 6th row, let's see. Row 1, row 2, row 3, row 4, row 5. Here's row 6. What number is the second number? The 4th term of the 6th row is, let's see, 1, 2, 3. It's that, but what is it in terms of chooses? What's this number here? Get your yawn out. What is it? What? So this is 5 choose. No. Start with 0. 5 choose. 5 choose. 5 choose. Okay. Can you see any kind of a relationship between the 4th term, 6th row, and 5, choose 3? What do you do? And I'm going to do that and that because they should be subscripts. The 9th term of the 14th row is what? We didn't go this far. It would be what choose what? Spot the pattern, folks. Wake up. Spot the pattern. So if the 4th term of the 6th row is 5, choose 3, what do you think the 9th term of the 14th row is? What choose what? Nope. Nope. 13, choose 8. See where the numbers are coming from? By the way, which is what? What is 13 choose 8? What is 13 choose 8? 1,287. So I'm going to ask you on your test a question like this. What is the 12th term of the 17th row of Pascal's triangle? Whoop. What's the answer? First of all, how do you calculate it? Have we spotted the pattern? Take the row number, first of all. 17th row means what? 16. Choose. Take the term number. 11. By the way, what is 16 choose 11? Because I'll actually want the actual number. If you filled out the first 17 rows of Pascal's triangle, by the way, I used to just say, hey, find the 12th term of the 14th row, and I would find on the back of the test some kid had done all 14 rows of Pascal's triangle because they'd forgotten the pattern. So then the next year I asked, like, find the third term of the 19th row. Then I found some kid had done 19 rows of Pascal's triangle. So it's evolved up to, like, find the 20th term of the 43rd. I've upped it so that there's no way a kid's going to draw it out, use the shortcut. And what I've tried to do, Sean, is if you blank on the shortcut, I've tried to show you how you can kind of puzzle it out. Hey, that's row 1, that's 0, choose 0. But you have to remember to start counting not with 1, to start counting with 0. This is a number 4 in row 5. The number 4 in row 5 is 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4. You can you can drive it if you forget 7. What is it, by the way? 16 choose 11? 4,368, and I don't need to fill out all 16 rows to figure that out. Okay? So on your test, simple question, hey, find me the, I don't know, 7th term of the 23rd row. Hey, what is the 7th term of the 23rd row? Find it. 7th term of the 23rd row. Go, find it. I'm not writing it out on purpose. 7th term of the 23rd row. What choose what? 22 choose 6, yes? Have we got the pattern? I'm not getting feedback, so I'm not sure if you're lost or just it gets first thing in the morning. What is the 7th term of the 23rd row? Which is? 74,613, and I don't need to fill out the whole triangle to find that out. Okay? Big deal. Oh, huge deal. You don't know yet, but trust me. I wrote here, so we're looking at patterns, and the first pattern is its relationship to NCR. It turns out that these are all chooses. Okay? There's also a symmetrical pattern. You may notice, look up, these two numbers are the same. You may notice these two numbers are the same. You may notice someone walking in late. You may notice I have to now pause my video lesson. Arg. So back to my little rant here. Justin, you notice these two are identical? You notice these two are identical. These two are the same. Those two are the same. In fact, you can kind of draw a line right down the middle of the triangle that's symmetrical. Why? Well, so we all filled in this row here. Underneath this, let's write the chooses, what this actually means. So what's the second number in my final row? What's this number right here? Come on, what's this number right here? 6. So this row is 6 choose 0. Write that underneath the 1. This 6 is 6 choose 1. Write that underneath the 6. What's that 15 actually? 6 choose 2. 6 choose 3. 6 choose 4. 6 choose 5, 6 choose 6. Why is it symmetrical? Well, here's a group of 1, 2, 3, 4, counting me, 5. Foster, can you join us, please? Here's our group of 6. Here's our 6 choose. Foster and I are going to form a group of 2. What other group did we automatically form? A group of? You can't form a group of 2 without forming a group of 4. Stay here. Which is why, if you want to know the number of groups of 2, 15, it's the same as the number of groups of 4, 15. Or, if Foster wants to be all by himself and form a group of 1, which he can, is it possible for him to form a group of 1 without automatically forming a group of 5? No. That's why 6 choose 1 is 6 choose 5. That's why it's symmetrical down the middle. I've talked about this before, but there's another reason. Thank you, Foster. You can sit down now. Okay? So, in terms of the symmetrical pattern, 5 choose 1 is the same as 5 choose 4. You can't form a group of 1 without automatically forming a group of 4. Is that okay, Christina? Make sense? Okay. I wrote down here justification, generalization. I'm not going to get into that. In Math 12, in the old course, we did a lovely proof algebraically. I'm not going to. Instead, turn the page. Okay? Hello? I wrote here pathway problems revisited. And I need to give you, this is hard to define, but it's easy to show you with a picture. In pathway problems, there are what we call regular pathway problems and irregular pathway problems. Sean, you with me? Yeah. This first one is a look up, all of you look up. This first one is a regular pathway problem. This one is irregular. It's hard for me to explain. Can you see how they look different? Okay, bear with me. That's a regular pathway problem. These are both irregular pathway problems. Regular, regular, irregular. Regular, irregular, irregular. What's a regular pathway problem? When all of the big rectangles don't overlap at all and there's no squares missing. What's an irregular pathway problem? When you have, you can see, for example, well, in this one here, there's one big rectangle, one small rectangle, but do they overlap a little bit? That's irregular. Or, as in here, you got some squares missing. Okay? The method that I showed you, where you could go down, 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 right, 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 and turn it into a word, only works for regular pathway problems. Which number 1 is? We could solve number 1 by going like this. Right, 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 right. Down, 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 down. Cole, we could say, hey, that's a word. How many letters in this word grand total? How many R's? How many D's? So, how many pathways are there to get from A to B? 70? That method only works for regular pathways, not for irregular pathways. I'd like to show you a very cool method that works for anything, but I need you to put your pencils down. Ready? Watch. Kyla's going to look up before I freak. Thank you. Watch. 1. 1, 1. 1. 1 plus 1 is 2. 1. 1, 3. 3. 1. 1. Help me out.
4.
Help me out. What? 4. Help me out. Help me out.
4.
And by the way, what you can think is right here, it's 1 plus 0, because there's nothing over on the other side. So, 1. Hey, let's keep going. What goes right here? 5. Then? 10. Keep going.
10.
Call them out.
5.
Next. 15. Next.
20.
Next.
15.
Next. 30. Oh, Mr. Dueck. Next.
35.
Oh, Mr. What?
What?
Last one is what?
17.
Oh, come on. That's cool.
50.
That's the same answer as we got using the choose method. But you know what? That trick, using Pascal's triangle and writing it along, works for irregular pathways. Now, I have a little bit of advice for you. Unfortunately, I can't do this on my computer screen, but I learned in a hurry to do these pathway problems using Pascal's triangle. It's way easier if you rotate your paper 45 degrees so that A is right above B and you're working straight down. Your brain just functions better that way. So try rotating your paper and see if you can, without looking up, fill this one in yourself for part A, and then we're going to do part B together. You picked a bad time to be late. Sorry. Come on, that's kind of cool. Adding with triangles also solves pathways? Yeah. Most common mistake, by the way, kids make a dumb addition mistake or they get sloppy. Just be very, very careful. And once you've done that first one, once you've arrived at that wonderful 70 in the bottom right corner, just kind of look up so I know that you're done. Who needs more time? Y'all good? Okay. Now, I'll be honest. For a regular pathway problem, I'd still use the turn it into a word method way faster. But the turn it into a word method does not work for an irregular where your rectangles are overlapping or where you're missing squares. So, B. Put your pencils down. What we're going to do is we're going to do this together as a group. Then I'm going to remove it from the screen. You're going to see if you can do it yourselves. Okay? So call them out with me. We start out with a 1. Next. 1. By the way, always move all the way across. Don't go down until you finish the whole row, or won't be able to fill it in. And again, by the way, it's this square right here is technically coming from 1 plus. Hey, what's sitting right there? It's invisible. A 0, right? So keep going. 1. 2, 1. Call them out. Call them, besides Tiffany, what's next? 4, 6, 4, 10, 10. Now, careful, careful, careful. This square here is going to be 10 plus 0. Oh. A 10 drops down now. 20, 10. Bottom left corner. This square here is going to be 10 plus what's coming from this? Oh, nothing. So 10. Keep going. 30, 30, 10. 40, 60, 40, 100, 100. So, try that on your own. And again, the hint is rotate your paper 45 degrees so that A is right above B. I'm hearing something from somewhere. Is that from my computer? Is that from Foster's phone? Wow. You know what? We'll let the mob decide. All right. What's the 14th term of the 19th row of Pascal's triangle? What choose what? 18 choose 13, which is 18 choose 13, 8,568. What's the 7th term of the 15th row of Pascal's triangle? By the way, this used to make a really good multiple choice question because in my answer I would have 15 choose 7, 15 choose 6, 14 choose 7, and 14 choose 6 because there was a lovely 4 answers you could make and only one was right, and it was very confusing and kids had to know. It was 3,003. Find the number of pathways if you must always move down and right. This is a regular pathway problem. You can use Pascal's if you want, or you can say that this is 2 separate rectangles, 2 separate words, and then multiply the words together when you're done. I don't care which. I'll do Pascal's because it's kind of nerdily cool. I'm going fast. I might make a mistake here. Let's see. That's one way, but I'm not sure that's right. Let me do it this way. Woohoo! So let me walk you. 210, yes? Okay. So what are the arguments? Connor, because this is regular, you can do it 2 ways. Pascal's there, I filled it out. Or you could say, I have to go through this rectangle and this rectangle. Hey, what does and mean? What did we say? So that's where the times came from. I said the first rectangle is 3 rights and 4 downs. And the second rectangle is 2 rights and 2 downs. So that worked. But Pascal's got me the same thing. Is that okay? And by the way, if you're trying Pascal's and you're not getting the 210, I guarantee it's a sloppy math mistake, and show me later, I'll find it. That's the trickiest part is because you're actually, for that one question, doing about 30 mathematical operations when you're adding them all together, you got to do arithmetic 30 times in a row correctly, which for some of you can be a bit of a challenge. But the method is pretty cool. Turn the page. A taxi company is trying to find the quickest route during rush hour traffic from the train station to the football stadium. How many different routes must be considered if at each intersection the taxi must always move closer to the football stadium? So the taxi is not allowed to backtrack because that would be raising the fare. Okay? Let's do the first one. Again, I would rotate your paper 45 degrees so that the train station is right above the football stadium. Unfortunately, I can't rotate my screen that way. Is this a regular or an irregular pathway problem? Okay, then we're stuck with Pascal's. Try this one on your own, and I'll do it up here, and let's see if we get the same thing. Careful, Mr. Dueck. 35 and 15 is 50. 35 and 34. 50 and... I think. Go double check my math. Am I right? Yeah, okay. Again, the only thing is I'll do a dumb arithmetic mistake in my head, but the method works pretty good. I can't quite get it all on one screen. Here we go. Yep. Hey, if you got that, try B. Mr. Dueck, what do we do? What? Oh, let's. Okay. Is A okay? We're good.
Yeah.
Okay, let's try B. Just move down the sides of that city park, but don't go into that city park, and I think we'll be okay. Train station is in the top right, so here we go. To there. $56. No, yeah. 28, 21, 49. 56. 91. 49 and 56 is going to be 90 and 15. 105. 91 and 56 is going to be 147. 147 and 105 is going to be 247. 200 and... Anyone else? 42? Ready, Sean? Find the 7 right there. Got it? When I read across, do you have 7, 21, 35, 21? No? This, by the way, this is how you find your mistakes. Is you pick a row, go across, and if that row's wrong, you keep working your way back. So you don't have a 7, 21, 35, 21? Okay. Okay. Let's go with look up.
Yeah.
This one right here. Do you have 1, 4, 6, 4, 1? 14641?
No.
Oh. Do you have, look up, 121?
Yeah.
Okay. Do you have 1331?
1, 3, yeah.
Do you have 14641?
1, 4, no.
Oh, there's where you made your...
Yeah.
Okay. And oh, sadly, that dominoed all the way through. I usually make these worth 3 marks on a test, and if every mistake that I catch is 1 off.
Okay.
So it's tough to get 0. Yeah.
How do you know which building to start? Like what slide to start?
By the way, if you started on the football stadium, is that what you're saying? Did,
Okay.
did you start on the football? No, but that's okay, Christine. Did you start on the football stadium?
I started on the left.
Top left? There's no station. You got to start on one of the points. But for what it's worth, Christina, you actually raised a good point. You will get the, if you started at the football stadium and worked your way to the train station, you get the same answer. And sometimes it's easier to go backwards. There's a couple of diagrams. I'm not sure how to, if I go backwards, I won't even run into that. Because I guess the number of ways to get there is the same as the number of ways to go the other way. Yep.
Is it the same, like, side to side? Or, like, top?
Nope. Going from here to here?
Yeah.
I doubt it. I have to try, but I don't think so. Okay. Nope. And we are gonna, how far are we gonna get today, Mr. Dueck? A little bit further. Combination situations with at least or at most. There's gonna be some of these on your test. Guarantee it. So, student council decides to form a subcommittee of 6 council members. There are 12 student council members, 8 females, 4 males. 12 people grand total, 2 subgroups. How many different ways can a subcommittee be formed that consists of exactly 2 males? This is a job for a bucket. What are my subgroups? Females, males. How many females in the bucket? 8. How many males? 4. Now, how many people are going to be on the committee? Read the question. Sorry? 6? Okay. How many, what's question A saying? What are we picking? Exactly what? Okay, so if I do this, by default, how many females? Cool? Okay. So we wrapped our brain around the initial setup, and now all I'm going to do is tweak it. Okay, so Cole, what choose what, and what choose what? 8 choose 4, and means multiply. 4 choose 2, which is what? Seb, what'd you get? Do you have a graphing calculator here, my friend?
No.
It's
Right outside my locker.
It's right outside in your locker?
Yep.
Why don't you sheepishly go get it, and I'll beat you up later.
Sounds good.
Sounds terrible. Cole, what'd you get?
420.
Sorry, I missed that?
420.
420? What's the difference between A and B? Is it 420, by the way? Is A the answer, 420? Okay. What's the difference between A and B? No, they're not the same.
Least. Minimum of 2 males.
As soon as they say at least or at most or more than or less than, it's really worth it. List the cases. So at least 2 males, Sean, means what? I'll give you a hint. 2 or, and don't say or more. List all the cases.
3, 4,
Or,
4,
or,
5.
ah,
It's not, oh.
why can't you go with 5?
Because you're
Okay, so
Not 5
here,
males.
these are the cases. And Sean, what does or mean?
Or is plus.
Okay. I think we can use our same bucket and just modify. In fact, we've already done 2 males. That was 420. Or, how many males now? Cross out the 2, make it a 3. Cross out the 4, make it a 3. Or 8 choose 3 and 4 choose 3. Or 4 males means 4 and 8 choose 2 and 4 choose 4. So this is going to be 420 plus 8 choose 3 and 4 choose 3, 224, and 8 choose 2 and 4 choose 4, 28. 420 plus 224 plus 28. I probably could have done that in my head. 600, is 672?
Yeah.
Okay.
Why was 2 always 420?
Pardon me?
Why was 2 420?
We figured it out in part A, didn't we?
Oh, right.
So I said, why redo it? I got it right there. Yeah. C. At least one female. What does that mean? 1 or 2 or who? That's a lot of work. I wonder if there's a better way to do it. I wonder if instead of figuring out the number of ways to form a group with at least one female, maybe I could figure out the number of groups with no females and somehow subtract from a total. Because that'd be, I mean, I can do 1 or 2 or 3 or 4 or 5 or 6. It's not going to take that long. But I wonder if there's a way that I can get there a little easier.
You can't have it with just one female though.
Pardon me?
Because there's no like males to form the rest of the group.
Oh, Jordan. What's another? Did you hear Jordan with his little flash of insight? If we have one girl, how many guys do we need to finish the group? 5. How many guys are in the group to begin with, though?
4.
Okay, so even though it says at least 1, let's go like this. 1 and put a cross. We can't do it. Or 2, or 3, or 4, or 5, or 6. You know what? Mr. Dueck's going to say, too much work. I made up a bad question. I'm not going to give you one right. If you can do at least, I should have done at least 5 females or something, or at least 4. But I'm not going to give you one where you're having to crunch all this stuff. So don't freak out. Turn the page. I told you I was going to ask you some card questions. Here is the type of card questions you might see. Psst. Thank you. Here is the type of card questions you might see. Consider a standard deck of 52 cards. How many different 5-card hands can be formed containing at least, you know what, probably we should underline the word at least 3 red cards, at least. And it's a card question, you know what, that's a job for a bucket. There's my bucket. In this question, in part A, what are my subgroups? What are they breaking the deck into? Emma? Sorry? You know what? I'm even going to go red and black because I know the others are black. How many red cards in a deck? Give you a hint, half of them. Caitlin, you're right. 26. How many black cards? 26. Okay. At least, let's list our cases. So at least 3 red cards means 3 or Or,
5.
oh, they said just do a 5-card hand, so I'm stopping there. 5 people in this group, 5 cards in this hand. Okay. So if I'm going to do 3 reds, how many blacks?
2.
So the first one's going to be 26, choose 3, and 26, choose 2. 26, Z2, 26, choose 2. Or, okay, now we want 4 reds. How many black cards? 1. 26, 20, good gosh, Dueck. 6, choose 4, and 26, choose 1. Or 5 cards, no cards. Oh, 26, choose 5, and 26, choose none. Okay. Hey, maybe I can type this in one fell swoop. See, on the older calculators, this didn't stay on your screen, but I think I can. This is 26, choose 3, and 26, choose 2, or 26, choose 4, and 26, choose 1, or 26, choose 5, and 26, choose 0. Double check, did I type that right? 3 and 2, 4 and 1, 5 and 0, 26, 26, 26, 26, 26, 26. Do you get 1, 299, 480? Yeah. Hey, that's why getting 3 reds is not a good hand. Because you can get it a lot of different ways. Oh, this is at least 3 reds. With me? Yeah? Let's see, how much further am I going to get? Yeah, I can do this. B. At most, 2 kings. Folks, a lot of chatter going on. Please stop. Thank you. First of all, I think I need to draw a new bucket. Kings and, others. How many kings are in a deck? 4. How many others does that leave? Do the math. 48. Now, this is at most 2 kings. What does at most mean? What are the cases? I'll give you a hint. 2 or... at most means 2 or less, yes? So, or, 1, or, none. Okay. Try this one on your own. Let's see if we get the same thing. I'll freeze the screen. I guess it's going to be that. you get that?
Yep.
259 4400? Okay. Yep. Okay. How many cards are there in a deck? How many kings? 4. So how many others? So we're having to pick 5 cards. So if we're picking, because at most 2 means 2 or 1 or 0. So if I'm picking 2 kings, that means 3 others. That's that one. If I'm picking 1 king, that means I better pick 4 others. So I've got to pick 5 cards. That's that one. If I'm picking no kings, that means 5 others. Is that okay? Hey, by the way, explain, next one, why is 12 choose 8 the same as 12 choose 4? Because when you form groups of 8, you're automatically forming groups of 4. Okay? I'm going to skip the very, very last one, so I'm done. We were going to do a lovely algebraic proof. I'm not going to freak you out, but it is nerdily cool. Instead, what's your homework? This. Okay? So some pathways. I included the answers. Kick butt.